All right, this video we are going to cover section 11.2. We're going to have two videos for this section. This is part 1 of 11.2. We are going to talk about composition of functions, composite functions in this video. And in the next video, we're going to talk about inverse functions. So let's look at the definition of the composite functions. Okay, composite function. So firstly, we have two functions f and g, and this notation f circle g of x is kind of like a special notation, right? F circle, a small circle between f and g. This notation represents the composite function with the inside function g and outside function f. It is a composite function. G is inside because it is closer to x. G is the inside function. F is the outside function. We compose the two functions together. We have one function. And this notation actually is the same with f of g of x. So the first thing, whenever you see f circle g of x, the first thing I want you to do is to rewrite that notation as this. Okay, f of g of x. F of g of x. So what does f of g of x mean? It is a composite function. If we could describe a function as a machine, then a composite function would be an assembly line. Let me write it down. Assembly. Assembly line. How do you spell the word? Assembly line. So what is assembly line? This is one machine. This is another machine. You see the factories, they don't just have one machine, right? They have many machines altogether to have an assembly line. So if we describe one function, the first machine is going to be the inside function. The second machine, the inside function input x first. Okay, you apply g on x first, then you would have g of x. And then g of x, right after g of x, the output come outside of g is going to go inside of f. And then we apply f, we would have the output for the composite function. So you see what I'm saying here? So if we bring in a different variable, if we let u be g of g is going to be the input of f. Or I think where this is a Barbie doll, Barbie doll, right? So we can dress her up. First, the machine we're gonna put her x, f circle g of x. Remember, I asked you whenever you see f circle g, you translate that, rewrite that as f of g of x. You know that's a composite function. So how do we write this composite function? We always start from the inside. Okay, this is the technique you're gonna apply. You always from the inside, parentheses, and this is red parentheses. You have g of y. What is g of x? G of x is once you replace g of x with plus 5, you are done with the inside function. You only need to do this. So the output would be 1 minus the real and here. Is that doable? So first is, and then deal with the outside of x. Also a composite function, but this time inside function is f, outside function g x squared, right? Function g. The output, the input is star 5 more than the pattern of function g, the corresponding 5 plus 5. What is the input? This x squared. Okay? You have 6 minus x squared. That is the composite function g of f of x. Very important. Yeah, I hope you can repeat this part until it returns to you. We have 2 more parts to go. Part 3 listens to you. We have 2 more parts to go. Part 3. Part 3 we need to find the f circle g of -1. The first thing to do, part 3 we need to find the f circle g of -1. Remember, the first thing to do, rewrite the notation. Rewrite it as f of g of -1. Rewrite the notation. Rewrite it as f of g of -1. What does that mean? That means the value of the composite function 1, where we are looking for the output of this composite function as the input is -1. Still start from the what's number? G of x is x plus 5. Then what is g of is just 4, number 4, right? So far so good? Yeah. And what is f of 4 now? F of x equals, let me see, what is f? 1 minus 16, negative 15. So number 4, we are looking for g circle of number 4. This notation represents the value of the composite function at x equals 2, or the corresponding equals 2, or the corresponding output of the composite function as the input is 2. Okay? Yeah. How do we handle it? What is f of 2? F of x equals 1 minus x squared, 2. Once we get, before we finish this part, I want to point it out. One more thing is the notation. F circle composite function, f of g of x, with the inside function